When I add and subtract rational expressions with uncommon denominators, the first thing I need to do is create a common denominator so then I can add or subtract the two fractions to create one whole fraction. So I'm going to break down the two denominators if possible and then see if they have anything in common. So in my first denominator, I have x squared minus x minus 12. So since it is a trinomial, I am going to factor that using the British method or the box method. When I factor, I get x minus 4 and x plus 3. In my second fraction, I have x subtract 4 in the denominator. It doesn't simplify any further, so I'm going to leave that as it is. So now I can compare the two denominators. They both share the x subtract 4, so it's the x plus 3 that this second fraction is going to need to create the same denominator in both fractions. So I'm going to multiply that x plus 3 to the numerator and to the denominator. So this creates a factor of 1, so it's not changing the value of this second fraction at all, it's just changing its appearance. So I'm going to have my 3x plus 1 from the first fraction. And now when I multiply the x minus 5 and x plus 3 from the second fraction, they're two binomials, so I need to FOIL. So I'm going to take x times x to get a positive x squared. Then I'm going to take x times positive 3 to get a positive 3x. Then negative 5 times x to get a negative 5x. And negative 5 times a positive 3 to get a negative 15. Now in my denominator, I have the factored expression x subtract 4 and x plus 3. So there is only one of each factor because now they both have the same denominator. So in my numerator, I'm going to combine my like terms and put this in standard form. So I'm going to start with my x squared term. Then I'm going to combine my x's of a positive 3x, and a negative 5x to give me a positive x. And then my constants of positive 1 and negative 15 to give me a negative 14. So that expression is still over the x subtract 4 and the x plus 3. One last step that I need to look at is, can my numerator factor any further? So I would take my a term times my c term, so 1 times negative 14, and I want to see, do I have factors of a negative 14 that would add up to a positive 1, which is my b term. I do not. The only factors of 14 are 7 and 2 and 1 and 14, neither of which add up to a positive 1. So this is finished. The last thing I would need to do is to figure out what would make my denominator undefined. So that would be taking the x subtract 4 and the x plus 3 and equaling them to 0. I'm going to solve each expression to figure out which values do not work. So I get an x equal to 4 and an x equal to a negative 3. So all values are going to work except for positive 4 and negative 3.